In this video, I will explain you what is hysteresis. With the help of experiment, this will be better to explain. That is, I am keeping a ferromagnetic substance, a material, inside a solenoid. And across the solenoid, I am providing an AC circuit, AC power source. So AC, you know what does it mean by AC, right? Alternating current means now current will start increasing from 0. So this is an AC curve. It will start increasing from 0 and will become maximum value. Then current will decrease to 0 and current will start increasing in the other direction, which means initially it is positive, it is negative. Now what will happen? Current start increasing from 0 and become maximum value, then with the same direction that increases and becomes 0. After that what will happen? This will become negative and this will become positive. Now current flow in this direction. Initially current flown in this direction and now current is flowing in this direction. And here in this case starts from 0, go to maximum, then goes to 0. So current is giving both the direction. So hysteresis means is the loss of energy due to work done during the process of magnetization and demagnetization. Now see, when the current is flowing in one direction, this is called as magnetizing intensity, right? The solenoid, N into I, H is nothing but magnetizing intensity, and that is created by solenoid. Under the action of magnetizing intensity, the ferromagnetic substance will be magnetized, which means magnetization is the physical quantity produced here. So it will build magnetization in one direction, which means, say for example, this will become north and this will become south. Now after that what is happening? In the next cycle this will become negative and this will become positive. So immediately that could not return its polarity or the position of north and south pole. Basically what it has to do, once the current is doing in this direction, it will become north and south. Now when the current reverses the direction, this also have to reverse its polarity. This have to become south and this have to become north. Now with the help of graph, we will see what is happening inside. Okay. So this is the graph. Okay, I'll keep it down. Yeah, it's fine. I'll keep it here. We got bigger area here. Now this one is our input, right? This is x-axis input. This one is our output. What is the output? Magnetic field is the output. Magnetic field created inside the ferromagnetic substance. That is the output. Now we are starting from 0. As of now there is no current. We are starting from 0. H is 0 now, B is 0. Now we are increasing the value. So what will happen when we are increasing the value? When we are increasing the value of H. What is H? Magnetizing intensity. How we can increase? By increasing current. Because number of turns cannot be immediately controlled, right? So when we are increasing the value of H, the ferromagnetic substance will get magnetized. When that is getting magnetized, there will be a magnetic field produced in it. How the magnetic field is produced? Just connect with ferromagnetic substance, domain will be aligned. Now domain will start getting aligned. So previously domain was in this way. So it was forming a closed loop. Right. Now instead of this has started becoming aligning in one direction. But we know there are not infinite number of domains, right? There are limited number of domains. So it will start aligning one after another, and that will start building up in this way. And it will become a maximum value. After that, we don't have domains to get aligned with external magnetic field. So what will happen? This will increase along with magnetizing intensity. That is, magnetic field will increase according to magnetizing intensity, and that will become a maximum value here. So after that, though we are increasing H, B will not be increased. So it will become almost parallel. That is the maximum value that can be produced inside. Now what is happening? Now we are decreasing the current. So H is equal to mu 0 into, H is equal to Ni. Correct. Now we are decreasing the current and we have decreased the current and made 0. But what we have seen here is, though we are keeping H as 0, that is magnetizing intensity as 0, the magnetic field came to 0 back. Which means when the current stopped, now ferromagnetic substance has got certain magnetism. See, that is called as retention. There are some magnetic field inside which has got retained. So this is called as a retention. Retention is nothing but when we are keeping the value of H is equal to 0, once it is magnetized, so it has magnetized here, fully magnetized. Now we have kept the value of H is equal to 0, but there is certain magnetic field. This is called as retentivity. So I will explain. Retention is the value of magnetic field. Okay, retention is this value which remains in ferromagnetic material when H is equal to 0. So when H is equal to 0, this is the magnetic field which is remained in ferromagnetic substance. So this is retentivity or retention. Retention. Now we have to demagnetize. So demagnetize means magnetic field have to be brought to 0. So what we can do? We can send current in opposite direction. So initially it was plus and minus. We have increased the value to maximum positive and maximum negative. Then what we have done, we have decreased to 0, but still there is a magnetic field here. Now we will send current in opposite direction, plus and minus. Which means, so I is positive here, now we are giving I negative, this quadrant. So which is Ni. So we have kept on increasing the current and finally what we have seen is magnetic field has become 0. This is called as coercivity. Coercion, the verb itself means that forcing for something. So what we are doing here, we are forcing for this magnet for a demagnetization, for a complete demagnetization. So coercivity is the value of H, that is the value of H. In opposite value of H is magnetizing intensity. So H, what should be the value of H? That should be in opposite direction. So value of H in opposite direction, which will make B is equal to 0. So at this value of H, magnetic field is 0. So at this point, magnetic field is 0, right? Now we will still continue increasing the current and we will see that now the magnet inside it was north and south, right? Initially at this, after this point, after coercion, what will happen? This will become, south will become north and north will become south. Now magnetization will increase in opposite direction and that also till a limit. After that, domains cannot be reversed. Clear? Now, so this is complete magnetization, this is complete demagnetization. Now we will repeat the process. We will again start increasing the current in this direction. And this will reach here. So what we have done, we have increased the current and we have provided the H, that is magnetization intensity, so magnetizing intensity H, okay, magnetizing intensity for fully magnetized. After that there won't be any magnetization because it's a limit. At that point all domains get aligned. Now what we will do, we will decrease the current so that we will make current is equal to 0, but there are some retentivity, which means some magnetic field is remaining inside the ferromagnetic substance. Now to make it 0, we are increasing the current in opposite direction, but that value of H to make B is equal to 0 is called as coercion. Now again we are decreasing in opposite direction. Now it is fully magnetized here. It is fully magnetized here in opposite direction. So this, what is this? Fully magnetized in positive direction. That is positive direction. What I mean by positive, north to south, fully magnetized. Here it is fully demagnetized. Okay, here it is fully magnetized in reverse direction. That is now north here and south here. So this is north here and south here in this direction. Now at this point it's not a magnet, no poles. At this point south and north, once again north and south in this way, I mean one direction it is basically. So north and south in one way, fully magnetized, it's 0 completely. Now north and south in one way which is opposite to this one. That's all. Okay, so this is the concept about hysteresis. So retention and coercivity are very important terms from that. Make a note of it. Thank you.